Here at the Vision show in Stuttgart, we demonstrate our product in different kind of market segments. For the food and beverage, we propose our deep learning-based application to detect foreign materials into chickpeas. The demo is running on an embedded platform with an ARM architecture processor. The fact that we use the deep learning approach for the food industry is very interesting because actually there is a lot of variability in the shape, the size, or the color of vegetables or fruits. So a normal conventional algorithm has some hard time to deal with this variability, which is not the case for the deep learning approach. Another advantage of using the deep learning approach for this industry is the possibility to very easily maintain or evolve this kind of application, because if we need to detect a new type of foreign material, we just have to provide images featuring this new type into the dataset, again train the neural network, and then this new type of foreign material is taken into account without the modification of a single line of code of our application. So that's really nice.
Nowadays, traceability is a key aspect in every logistic process. To achieve this traceability, companies usually print codes on the parcels. The most common codes are barcodes, QR codes, and data matrix codes. The problem for a vision software is that you never know in advance which type of code will be present on the parcel. To achieve this challenge, Euresys developed a unified code reader that is able to automatically detect the codes present on an image and decode them. With this, we can know the final destination of our parcel automatically. But now that we know the final destination, we may want to automatize the palletization and crating of those parcels with a pick-and-place robot, for example. But the challenge for this is to know the exact position and the size of this parcel. To address this challenge, Euresys developed Easy3D Object Library, which is able to automatically extract data from the point cloud or the ZMap and compute its localization and sizes of the parcel for automatic palletization and crating. So here on the screens, we have on the left the automatic code reader, which detects the barcode, the QR code, and the matrix code from the image. And on the right here, we have the object extraction from the point cloud, and we have the measurements of the parcel.
Hello, I want to demonstrate one of our last developments, CoaXPress-over-Fiber at high speed at 100G. So what you see here is a demonstrator for a camera, front board, a demonstrator for a host, for a frame grabber, and the second board where we connected the monitor. And this CoaXPress IP is beneficial for you if you want to do your own hardware, your own camera, and reach highest bandwidth.
For the electronic and semiconductor markets, we want to showcase our Coaxlink Quad CXP12 value frame grabber in a high-speed image acquisition demonstration. So just to give an idea about the frame rate, for image resolution of 200 pixel by 200 pixel, we can reach a frame rate of up to 125,000 frames per second. For the image analysis parts, we are using our EasyGauge library for the measurements of micro SD card, so we are checking the conformity of those components.
GigE Vision 3.0 will be the next big release in the GigE Vision specification, and here we have already a preview to demonstrate the new features. You'll see a camera demonstrator on an evaluation board, FPGA evaluation board, what could be the basis for your own design. You see also already a camera running this GigE Vision 3.0. Yes. The main new feature is that for higher data rates, GigE Vision will incorporate remote DMA, the Rocky V2 protocol, to benefit from offloading functionality of modern network cards. So no CPU is involved anymore, and this network card will directly copy the payload into memory without need of CPU power.